Good day to all of you. Today we shall discuss on question number 10a from model question paper set 2 of the subject digital design and computer organization with subject code BCS302. The question is as follows. Explain the complete set of operations involved in executing the instruction add in bracket R3, R1 along with control sequence. This carries 10 marks. Our sincere acknowledgement and thanks to author Karl Hamacher of the textbook with title Computer Organization 5th edition. The content of whole discussion is taken from this book. Let us now discuss on what all operations or actions are required to execute the given instruction add in bracket R3, R1. So first this instruction will be there in memory that has to be fetched. So the first action needed is fetch the instruction. Next, in that instruction addition is stored, hence the second action is fetch the first operand, that is the content of memory location pointed to by R3. So bracket R3 here indicates it is memory location address. In that first operand is present and that has to be fetched. That is the second step. Third, perform the addition. Add is the instruction, means addition operation must be performed. So first operand from R3 pointed memory, it is fetched into processor. Second operand is present in processor register R1 only. So both are to be added. That is what is perform the addition. Next, fourth step is load the result into R1. Finally, when both the operands are added by ALU, so ALU generated result must be stored in R1. So to do these actions by different parts of the processor here, instruction decoder and control logic, they will generate control signals and activate different parts in some specified sequence. So next we'll have to discuss on the steps which indicate in each step which all control signals will be given. Here we can see control sequence for execution of the instruction. Totally there are 7 steps in the control sequence. In the first step, some control signals are given and likewise in second, third and so on till 7. The steps 1, 2, 3 are required for fetching the instruction from memory, that is to fetch add in bracket R3, R1. That instruction where it is in memory, from that location it is fetched into processor instruction register IR. Next 4 to 7, the steps 4 to 7 are needed to execute the fetched instruction. So we have to know how this instruction is executed by the processor. So for that what actions are needed? They are listed here as 4 actions. To perform these 4 actions, what control sequence is needed? That is specified in 7 steps here. So next, taking processor model means single bus architecture for data path that we have to take. That is the processor model, or it explains what all parts are there in the processor, how they are connected and how they are to be operated. So taking that, we shall discuss how this instruction with these 4 actions and 7 control steps it will be executed. Okay, this is the diagram showing the processor model, means the processor has which all parts, how they are connected and how to operate them, and whatever actions are intended to execute the present instruction, what control sequence are chosen in 7 steps, how in each step different parts of the processor will be activated and they will perform the actions needed to execute the given instruction. So that brief discussion we shall have first and get to understand this, and next we shall go to the actual discussion of the control sequence. Okay, so the processor has program counter, that is PC. It always stores the address of next instruction whenever the processor is executing a program. This is MAR, memory address register, which holds the address of memory location with which processor wants to communicate for read or write operation. This is MDR, memory data register. Through this register, processor will send the word to memory, or whenever it fetches a word from memory, that is loaded into MDR. From there it is taken to processor register. That is, through MDR only processor will send the word to memory or take the word from memory. This is ALU, arithmetic logic unit, that performs arithmetic or logical operations on the given two operands A and B, and it gives the result, and that result will be stored temporarily in general purpose registers here. So R0 to Rn-1 are the general purpose registers. They are used for temporary storage of data. This is internal processor bus that connects the different parts of this processor. This is instruction register, that is whenever an instruction word is fetched from memory, that is saved in instruction register. From here it is given to instruction decoder. Will decode the instruction and assess what operation should be done and where are the operands. And control logic accordingly generates control signals, sends to different parts of the processor as to activate them to execute the operation specified in the instruction. So that is all about the different parts of the processor. With different internal parts of the processor, what kind of operations are needed? So the first kind of operation is to transfer a word of data from one processor register to another or to the ALU. Means here there are different registers in the processor. Between the registers the data has to be transferred, and between ALU and register also. That kind of operation is needed. That is first kind. Secondly, perform an arithmetic or logical operation and storing the result in processor register. So next, fetching the contents of given memory location and load them into processor register. Then storing the word of data from processor register into a given memory location. So with this we come to know that there are four kinds of operations needed by different parts of the processor. That is communication between the different registers of the processor, then between processor register and memory, and next ALU performing arithmetic or logical operation. So next the result obtained by ALU must be transferred to register. So these kind of operations are needed by different parts what we mentioned in the processor model now. Okay. So next we shall discuss how MDR is operated through four control signals. So here this is the place of MDR that comes between internal processor bus and external memory bus. So here it is shown in the magnified form. So MDR is connected to internal processor bus and external memory bus. So whenever processor wants to read a word from memory, that memory will have put that word onto data lines of the external bus. That is memory bus data lines. So to take this into MDR, MDR in E control signal is sent. Then the data from memory data lines, it is copied to MDR. Next, MDR out control signal is given. Then content of MDR that will be put onto internal processor bus. From here it is taken into different register of the processor. So this is a read operation performed by the processor through MDR. Next, how processor performs write operation through MDR. So processor will have put its data onto internal processor bus. Then MDR in control signal is given. Then from this internal bus the data is copied to MDR. Then MDR out E control signal is given. So from MDR that content is copied onto memory bus data lines, and from here it will be sent to the memory location specified in the instruction. This is how using MDR processor will communicate with memory for read and write operation. Through MDR only it will send the word to memory or it will take the word from memory. Okay. So this example shows how control signals are used for inputting the data and outputting the data from a register. Okay. That is MDR here, memory data register. What are the two diagrams that we referred for this? The first one is single bus organization of the data path inside a processor, that is one, and the second one is connection and control signals for register MDR. Okay, so the diagrams are very important here, right? Similarly, for registers also, the control signals are needed to put data into the register and to take the data out from the register. So the control signals needed are, so concentrating only on registers, general purpose registers. So this is Ri, that may be R0, R1, R2 till Rn minus 1. Okay. So this is the internal bus. So while putting the data into the register, processor will put the data onto internal bus. Then Rin control signal is given. Hence, from processor bus, the data will be saved into register. So this is inputting the data to register through Rin control signal. Suppose if content of register has to be taken out, then Rout control signal is given to that register. Then from that register, the data is put onto processor internal bus. From there it is copied to any other register. This is how through two control signals, Ri in and Ri out, any general purpose register can be used for data storing into that or data taking out from that. Okay. So before going to the discussion of the execution of actual instruction, that is add in bracket R3 comma R1, let us take a simple example and get to know the usage of control signals. So here example instruction taken is move R1 comma R4. So move means copy the content. So R1 is the source here, R4 is the destination. So from R1 register, its content is copied to R4. That is what is shown in the diagram here. So the actual control signals are not shown, but we have dealt with them in depth. It is understood that to take out or put in, the control signals are needed. Since the data is copied from R1, first R1 out control signal is needed, so that R1 register will put the its content onto internal processor bus. Next, R4 in control signal is given to R4 register, so that whatever data is on internal processor bus, that will be copied into R4. These are the two control signals given in single step. Means they are given at the same time. At the time at which R1 gives out its content onto internal processor bus, at the same time R4 will take that data into it. So this is one step of control signals which is needed to execute the instruction move R1 comma R4. Actually this is a very simple instruction because the data transfer operation between the two registers is involved here. No memory is involved. Okay. So with the understanding of how control signals in a step can activate different parts of the processor for the needed operations, we shall go to the discussion of add in bracket R3 comma R1 instruction. So how it is executed and how the needed 4 actions through 7 steps of control sequence, the actions are performed. That we shall discuss now. That is the actual topic. Okay. So let us start discussion with the first step of the control sequence. In that first control signal is PC out. Means program counter will output its content. Means the address of the memory location. Means the first instruction address, that which is stored in PC, that will be outputted onto internal processor bus. This is because of PC out control signal. Next we have MAR in, that memory address register takes this into it. Means whatever address of the present instruction was coming, that will be loaded into MAR register. Hence it will be available on address lines of external memory bus. So it will reach to that memory location where the instruction add in bracket R3, R1 is stored, because first three the steps of control sequence are to fetch this instruction. In that first step we are discussing. So read signal will be sent to that memory location. Next we have select for control signal, that is this. It will select this constant 4 as one operand here, that is operand A. So next we have add control signal. It will add A and B, means this constant 4 and whatever instruction address was put onto internal bus, that will be added. So next instruction address is generated. So that will be stored in Z because of Z in control signal. So these are the actions taken by step 1 of control sequence. Okay. Next, second step of control sequence. In that first control signal is Z out. So the addition of present instruction address and plus 4, that was next instruction address which was stored in Z register. Z out control signal will put it onto internal processor bus. PC in will make it be stored in program counter. Next Y in, the same is stored in Y in register. So here next instruction address, why it is stored in Y register also instead of only PC, because if instruction is of multiple bytes, it will be stored in multiple memory locations. Hence to generate next memory location address along with constant 4, this is required. That is why it is stored in Y. So okay. So next WMFC means wait for memory function complete. So wait for memory function complete means to whichever memory location the processor has sent read signal where this instruction is stored, till that memory location puts this onto data lines of external memory bus. So processor has to wait. When it completes putting this instruction word from its content onto data lines of external memory bus, it will send memory function complete signal to processor. So this signal makes processor wait till memory completes that operation. Okay. Next, step 3 of control sequence. So in this first control signal is MDR out. So by this time wait for memory function complete will have been over. Memory will have completed its work. Means this instruction word it will put from its location onto data lines of external bus. So this MDR out control signal is given to MDR. So whatever this instruction is loaded into MDR, that will be outputted onto internal processor bus. So IR in control signal will take this instruction into it. This is how the instruction which was stored in memory location, that is loaded finally into instruction register of the processor. Okay. Now fourth step of control sequence. The first control signal is R3 out. R3 out in the sense, if you refer to this instruction, add in bracket R3 comma R1, means R3 has the address. So address of the first operand. This is first operand, second operand is in R1. So R3 holds the address. This bracket R3 means address of the memory location where first operand is present. So now first operand has to be fetched, hence that address is outputted from R3. So R3 is here, R3 out signal will put its content. that address of first operand onto processor bus, internal processor bus. MAR in will make it be loaded in memory address register. So onto address lines it will go to that memory location where first operand is stored. So that is what is bracket R3, that is accomplished. Read signal is sent from control logic to that memory location. Okay. Next, fifth step of control sequence. In that first control signal is R1 out. So R1 is here. R1 out means in the instruction R1 holds the second operand. So that will be put onto internal processor bus. So next Y in. So that will be saved in Y in register. So second operand will be in Y in. Then wait for memory function complete. So wait for memory function complete means bracket R3 was sent, that first operand was being fetched. Now wait for memory function complete means till that being brought and be loaded in MDR, the processor will have to wait. So it is waiting now for the first operand. Second operand is already loaded in Y in register. Okay. So next, step number 6 of control sequence. In this, the first control signal is MDR out. Y is also given. Here in previous instruction the last was WMFC. So processor was made to wait till memory completes its function. That function means R3 pointed memory location content was asked. So in that first operand was present. So memory is slower. It takes time to put that onto data lines of the memory. So this select Y, it is given to mux. What it does, so whatever is in Y register, it will select, means it will come at the output of the multiplexer. That means to the A input of the ALU. What was there in Y? In previous control sequence, R1 content was put onto internal processor bus. From there it was saved in Y in. Hence in this control sequence when select Y is given, that R1 through mux it is given to A input of the ALU. Hence at the A terminal we have the operand R1. Next, when memory will have put R3 pointed memory location content, that is the first operand in the instruction, onto data lines of the memory bus. Since MDR in E is always logic 1, it will automatically take into MDR. This MDR out will send it to processor internal bus, and that will be naturally be available at B input of the ALU. This is how we have R1 at A input of ALU and R3 pointed memory location content at B input of ALU. Then add signal is given, it will add both. Z in will take that result into Z. So this is what is accomplished in step number 6 of control sequence. Okay. So next, seventh step of control sequence. Z out. This control signal, what sum was saved in Z register, it will put onto processor bus. R1 in control signal will take that sum and be put into R1 register. And end signal, that is the end of instruction execution of the instruction, add in bracket R3 bracket complete comma R1. So that is the end of the discussion regarding how add in bracket R3 bracket complete comma R1 instruction is executed. Okay. So this is from where we started answering the question. Explain the complete set of operations involved in executing the instruction add in bracket R3 bracket complete comma R1 along with the control sequence. So for that we listed needed 4 actions and 7 steps of control sequence. Next we moved on to single bus organization of the data path inside a processor. for all the basics needed to answer this question. So, we discussed in depth on the following topics: data path, four different kinds of operations needed to execute an instruction, connection and control signals for register MDR. In this processor, how MDR is operated with the four different control signals. Example instruction move R1, R4. Finally, continuing from the actions and control steps for the asked instruction, we explained the different steps of control sequence starting from first, second, third, fourth, fifth, sixth, and lastly seventh. That completes the whole discussion. I hope you understood. Thank you.